Our Father in heaven, thank you so much for the beauty that you've given us in creation, and thank you for Neville, that you've given a sharp mind and a deep insight to be able to understand mathematics and the way that it reveals you. Lord, I pray that you be with him, and I pray that you would speak through him this afternoon. In Jesus' name, amen. Now, on your pews, you will have a little piece of paper. It says, I have a question. You're welcome to write a question on that piece of paper. If you don't have a pencil, I think the deacons have some pencils. So does anyone here not have a pencil? So I can send the deacons around. Everyone pretty much got pencils, pens. So yeah, for questions. Also, if you want to put my number back up there again, guys, if you got that handy, you can also text questions to my phone number as well, and I can send them on. Now, the questions will not be answered immediately. After the three presenters have had a chance to speak, then we will have a panel discussion, and all three of them will have the opportunity to answer the questions that you're posing. We also, on the pews, have little decision cards as well. So we'll be collecting these along with the offering at towards the end of the program. The offering will be going towards covering the cost of the event, and also potentially, if we have extra, running the event again. So please do be prepared to give for that offering. But the decisions here are general decisions, and they may not all apply to you, and that's okay. You just tick the little box of the one that applies to you, and you can put your details on there and put that in the offering bowl. So I think without further ado, Neville, I invite you to come up and speak to us about design in mathematics. How many minutes? How many minutes should we give him, Sven? How many minutes have you got? 45 minutes.
Oh, no, it won't take that long.
All right, okay.
Well, good afternoon. We think of Sir Isaac Newton as the father of modern science. And another name that you're probably aware of is that of Kepler, Johannes Kepler. Both were Christians, both believed in a creator, both believed in a lawgiver. And because they believed in a lawgiver who gave moral laws, they also believed that you would find his footprint in nature. And this afternoon I want to show you some fascinating things, and I think you will enjoy what you're going to see. Some fascinating things from the field of mathematics. It won't be advanced mathematics at all. A lot of it will draw upon nature. And so without further ado, let's take a very simple case. Let's suppose I wanted to add all the odd numbers from 1 to 99. Well, you could do it laboriously, but is there a pattern? Is there a design here? You'll notice that 1 is 1, of course, and 1 and 3 gives 4. 4 is 2 squared. 1 and 3 and 5 give 9, which is 3 squared. And so the sum of the first 3 is 3 squared. The sum of the first 2, 2 squared. What about the sum of the first 4? Well, 16, 4 squared. So what would you expect the sum of the first 5 to be? 5 squared. All right, how many odd numbers from 1 to 100? Well, clearly there's 50, half of 100. So the sum of the first 50 should be 50 squared, which is 2,500. A similar pattern exists for the even numbers. And there you see that the sum of the, well, we'll start with the second row. The sum of the first 2 odd numbers, even numbers, is 6, which is 2 times 3. The sum of the first 3, 12, 3 by 1 more than 3. The sum of the first 4, 4 by 1 more than 4. So what about the sum of the first 50? 50 by 1 more than 50, namely 51. We know 50/50s are 2,500, so the answer will be 2,550. Now I could show you pattern after pattern that's like that. Did they just happen by chance? Now, I know that men invented symbols and ways of representing mathematics, but did they invent mathematics itself, or was it discovered? And in fact, Euler, who I'll mention later, said that mathematics gave him a window into the mind of God. And that's what I'm suggesting we're going to see this afternoon. All right, here are a couple of sequences. First one's pretty simple. You could tell me the next number. What is it? 13. Each one's increasing by 3. What about the second sequence? What's the next number? 21. Yes, it's 21. Now you might wonder, how did she get that? Well, if you look carefully, each number is the sum of the preceding two. So for example, how did I get 5? By adding 2 and 3 gives 5. 3 and 5 give 8. 5 and 8 give 13. 8 and 13 will give 21, and so on. And so you get this sequence. It's called the Fibonacci sequence, named after an Italian mathematician by the name of Fibonacci. And there are a lot of interesting properties in it. If you take any 3 numbers, any triple that's in ascending order, let's take, for example, 3, 5 and 8. If you multiply the first 3 by the third 8, what do you get? 24. If you square the middle, 25. The difference, 1. That works for any triple that you might like to take there. Take 5, 8, 13. 5 13s is 65. 8 8s, 64. Difference 1. Take 4 consecutive ones, any 4. All right, let's take what? 2, 3, 5 and 8. If you multiply the outer ones, 2 and 8, you get 16. If you multiply the inner ones, 3 and 5, you get 15. Difference 1. And as I say, that works for any lot. Now, another interesting thing in this sequence is that especially as the numbers get bigger, if you take any number and divide it by the one before it, you get 1.618. And that's called the golden ratio. And it has some tremendous applications in nature, as we're going to see. All right, we mentioned the Fibonacci numbers. Well, here they are. 2 to 3, so if you look at your various joints in your finger and so on, 2 to 3 to 5 to 8. Now this doesn't work for all flowers, but quite often the number of petals on flowers are a Fibonacci number. So in this case you've got 5 petals. As I say, it doesn't always work, but usually it does. How about that? So this to this is in the ratio of 1 is to 1.618. Florets on sunflowers are arranged in spirals, and you'll notice that some spirals go in a clockwise direction, some go in an anti-clockwise direction. The number of florets, spirals rather, will always be one of the Fibonacci numbers, and in this particular case, you've got 21 going in the anti-clockwise direction, 34 in the clockwise direction. On some sunflower heads, it's 34 and 55, but they're still numbers from the Fibonacci sequence. And then you've got the case of leaf distribution, and you can study that one out further, because I've got a fair bit to get through. All right, we're going to now progress from there to what's called the golden rectangle. And the golden rectangle is in the proportions of 1 is to 1.618. And we're going to see in a moment where God has used this, because God is the great geometer as well as the great numberer. All right, start off with a square. You can see the square there, A, B, C, D. I've taken the midpoint of AB. Then using E as centre and a radius of EC, I've scribed an arc. And where it meets AB produced at F gives the third point of what's going to be a golden rectangle. And then it's easy enough to complete the rectangle. Now the interesting thing here is that that complete rectangle is made up of a square and a rectangle, and that rectangle happens to be golden. So you can kind of keep going like this. So we've got the square, and then in that other golden rectangle, I'll square off the bottom. That leaves a golden rectangle at the top. Square it off, and so on. Now let's join them up, not with straight diagonals, but kind of curving ones. And there is the golden spiral. And the Lord has made use of that. There. Spiral nebula. A lily. Now, of course, men like the golden rectangle, and there are plenty that you can note in there, but so does God. Now, in the human face, this distance, the height of the face, the length of the face, if you like, is 1.618 times the width. The distance from the top of the nose to the middle of the teeth is 1.618 times from the middle of the teeth to the chin. The width of the mouth, yes, the width of the mouth to the width of the nose is that. Now I better stop there because I know Glenn's going to be talking tomorrow something about in the human face. But there are a lot of interesting applications, and here it is to dentistry, but I'll skip it. So there we've seen examples of where mathematics in nature has shown tremendous design. Could it have just happened by chance? Now sometimes people say, oh, you fellas, all you do is, when you find something that's a bit hard to explain, you attribute it to a God whom you've never seen. Okay, well, how do you explain it? Oh, well, random processes that took place over eons of time. Okay, let's check them out then. Which is the more reasonable? Which would be the more scientific for that matter? Well, this laptop that I'm using here, I didn't see who designed it. I didn't see it being designed, but I know it has a designer. The same goes for my watch. All right? So because I have observed this, it's not a very big leap of faith for me to believe that this other implies a designer. On the other hand, I've never seen a tornado go through a junkyard and produce order. Certainly over in Venezuela at the moment, that earthquake hasn't brought about any order. So I think mine is the more reasonable faith. All right, now in front of you there, I've got what are called regular polygons. Look, the face of this is a regular polygon. It's a square, and all of its sides and angles are equal. Here's another one. All of its sides and angles are equal. All right, so we've got the equilateral triangle. Each angle is 60 degrees. The square, each angle 90. You've got a regular pentagon, each angle being 108. A regular hexagon, 120, and so on. Which of these will tile the plane? That is, which ones would fit together? Say you're trying to use some of those shapes for your kitchen floor. Well, equilateral triangles fit together, and the reason for it is because each angle's 60 degrees, so 6 of them meet at a point, and 6 60s give 360. Similarly, squares tile, because each angle's 90 degrees and 4 90s 360. Why won't regular pentagons tile? Because each angle is 108 degrees. So if you fit 3 together, what have you got? 324 degrees, not enough. And if you try to fit 4 together, they'll overlap. So we can see that it wouldn't tile. The regular hexagon certainly tiles, because 3 lots of 120 give 360. They're the only regular plane shapes that will tile a floor. I'm not talking about ones like bricks. They're not regular. Not all of the sides are equal. Okay, let's now extend that to 3 dimensions. Why does a bee have a hexagonal honeycomb? Why is it designed that way? Now, one reason could be, as was suggested, maybe it is a bit stronger. It certainly accommodates the shape of the bee well, but there's another reason. If I were to give you a metre of string and you were to make out of it an equilateral triangle, and then with another metre of string you make a square, and with another metre of string you make a regular hexagon, the equilateral triangle, each side would be 33 1/3 centimetres for the square, 25 for the other one, 16 2/3. Which one has the greatest area? The regular hexagon does. So if I now transfer that into 3 dimensions, for a given amount of beeswax, you get maximum volume with the hexagonal prism, and so that's why the bee uses a hexagonal prism, or one of the reasons. Who taught the bee that? And in fact, who taught the bee this? A worker bee goes out and finds some nectar, needs to come back and communicate to the worker bees where there's a source of nectar. Now, what does it need to communicate? Well, first of all, it needs to communicate direction, and because bees are short-sighted, it also needs to give the distance. How does it communicate direction? Well, when it returns to the hive, it does what's called a waggle dance, a figure of 8 kind of a dance. And the angle through which that part that's sort of going northeast, I should have had a pointer, that doesn't matter. The angle between it and the vertical gives the angle that it should fly away from the current position of the sun. So that gives the direction. As it goes through the dance, it waggles its abdomen, and the number of waggles gives an indication of the distance. Now, we were talking a moment ago about regular polygons, plane, 2-dimensional shapes. Let's now apply it to 3 dimensions. And if you can see these here are regular polyhedra. Now, we define them as follows. The shapes have to be regular polygons, and the faces have to be regular polygons, and all the faces have to be the same. They have to be congruent, the same shape, the same size. Furthermore, you have to have the same number of faces meeting at a corner, at a vertex. And if all 3 conditions are satisfied, then you come up with 5 regular solids. The simplest one has 4 faces. They're equilateral triangles. It's called a tetrahedron. Tetra for 4. This has 6 faces, so it's the hexahedron, commonly called a cube. This one with 8 faces would be called what? Octahedron. Now, the word for 10 is deca, but if you want 2 more than 10, that's dodeca, and this is a dodecahedron. And this one is called an icosahedron. It's interesting to count up the number of faces, vertices, and edges for these. So as you look at that, how many faces has it got? 4. How many corners has it? Vertices. 3 around the bottom, 1 on top, 4. How many edges? 3 coming down, 3 around the bottom, 6. And so you end up with that. All right, to save time a bit, there's the cube. And you find it's got 6 faces, 8 vertices, 12 edges. Octahedron, well, we'll do this one. How many faces? 8. How many corners? 1 on top, 1 underneath, 4 around the middle, 6. How many edges? 4 coming down, 4 going up, 4 around the middle, 12. That's a bit interesting. Between the cube and the octahedron there. All right, well, if we keep going, here's the dodecahedron. That's what we get. Here's the icosahedron. That's what we get. And you notice the dodecahedron and the icosahedron look a bit similar too. We call that duality. So there's a duality between the cube and the octahedron, and there is between the last two. If I were to tell you the number of faces and the number of vertices, could you tell me how many edges there were? Is there a relationship connecting them there? So let's say I told you that something had 30 faces and 20 vertices. How many edges would it have? Because actually this works for all shapes, all three-dimensional shapes. Can you see there that if you add the faces and the vertices and subtract 2, you get the number of edges? That just happened. Or is there design here? Now, are there any applications of this in nature? Sure. Methane molecule, CH4, meaning it's got a carbon atom and 4 hydrogen atoms. And the way that they repel and so on each other, they're in that shape. That's not an artist's impression, that's the way they occur. That's right, isn't it? Yeah. And here we have, for the cube, table salt crystal, a diamond crystal, octahedron, parietal crystal, dodecahedron, boron 12, icosahedron. Wow. Now, something different. If we have, so I'm working in the one plane here, so we'll call these coplanar. They all lie on the same plane, so we're in 2 dimensions. Any 2 non-parallel lines will meet in a point. If I have a third line introduced, it'd usually do that, wouldn't it? They'd meet in 3 points, meet in pairs. I think you would have to admit that that's a special case and that the probability of that happening is much lower. All right, let's apply that now to a triangle. This is any kind of a triangle. It's not a special one. It's not equilateral or isosceles or right angled. It's an ordinary triangle, scalene. And a median is the line that joins a vertex to the midpoint of the opposite side. What if I draw in all 3? Wow. They all meet in the same point. It's actually called the centroid. It's actually the centre of gravity of that figure. And here I've got a triangle that has been, in which I've got the medians, and that balances. It's the centre of gravity of the figure. And there's more. There are lots of things here. I'll just share one of them. That point is 1/3 of the way along each median from the side to the opposite vertex. And it doesn't matter which median you take. Now let's take a triangle, and this time, instead of doing that, let's take the perpendicular bisector of each side. Do they meet? And how? Yeah, they meet in a single point too. Not only that, but that point happens to be the centre of the circle that passes through the 3 vertices. So if you've got 3 points on the ground and you want to draw a circle through them, what do? Join up the sides, get the midpoint, go at right angles, and where they meet, that'll be the centre of the circle that you need. What about angle bisectors of a triangle? Yeah, they all meet too in the 1 point. And that happens to be the centre of the circle that fits snugly inside, each side being a tangent to the circle. Wow. And what happens if you drop perpendiculars to each side? Well, they all meet too. And that's called the orthocentre. And there are a few things about it, but one thing I'll share with you, it always lies in the same straight line with both the circumcentre and the centroid, no matter what triangle you have. In fact, if it's equilateral, they all coincide. I mentioned Kepler earlier. Now, Kepler came up with the laws of planetary motion. And his first law is that planets move in elliptical orbits with the sun at one of the foci, one of the centres. An ellipse kind of has 2 centres. I don't know whether you ever tried to draw one, but if you want to, put 2 pegs in the ground, or if it's on paper, 2 pins or something, and have a piece of string, or in the case of on the ground, rope. And if you keep it taut, you can go around and you can produce an ellipse. And those 2 pegs are what we call the foci. Each one's a focus. Now, in the case of Earth, they are almost together. The Earth's orbit is almost circular. Not quite, but almost. And there's a good reason for that too. Kepler's second law said that these planets will sweep out equal area in equal time. So the area that's on your left there is the same size as the one on the right, but the one on the right doesn't have as far to go, so it's going slower there than when over the other side. So planets move more quickly when they're closer to the sun. And there's a third law too that we won't worry about. But this is what Kepler believed. He believed in the harmony of the universe put there according to God's design. He traced out that harmony in his 3 laws of planetary motion, and he prayed, "I give thanks to thee, O Lord Creator, who hast delighted me with thy makings, and in the works of thy hands have I exalted." And that brings to mind Sir Isaac Newton. And Newton made numerous discoveries, but maybe you're not aware of the fact that probably he spent more of his life studying the scriptures than science. In fact, he was particularly interested in the books of Daniel and Revelation. They say that he made most of his scientific discoveries in the 2-year period when the university where he worked was closed down due to the Black Plague. But as Newton made his discoveries, he said that he regarded himself as a small boy playing on the seashore, every now and then finding a prettier pebble or a prettier shell, while God's great ocean of truth lay out before him. And here are some of his accomplishments. Here are his laws of motion. Then you can look at mathematics and music. And I want to show you this one. Now, this one is attributed to Gerhard Desargues, 1642, came up with this famous theorem. And by the way, he was a Christian who believed in God. This is in 2 dimensions. In a minute, I'm going to show you it in 3. So if you have if you project this first triangle, the little one that's labelled A dash B dash C dash, from O, if you can kind of follow this. Now, the maths till now has been pretty simple. Projective geometry that we're looking at now is a bit more advanced, but this is a simple example and I think you should follow it. So notice that A dash has been projected into A, B dash into B, C dash into C. They're not necessarily parallel, in fact they're not there. If you produce A dash C dash and AC, so the ones that are labelled somewhat the same, where do they meet? The ACs meet at, what's that one there? S. The BCs meet at T and the ABs meet at R. And they're all in the same straight line. And no matter how you do it, every time you'll find that those 3 points are in the same straight line. That incidentally shows you how to draw 10 trees, or plant 10 trees in 10 rows of 3. Because if you look at that, you'll see that there are 10 lines, there are 3 points on every line, and there are 3 lines through every point. Interesting figure, isn't it? Here it is in 3 dimensions. So I'm going to interpret it this way for the minute. So there's the centre of projection there. Can you see this little triangle here? Okay, so that point projects into that one into this one, and this one into this one. So you've got this little triangle up here going into this one here. When you produce corresponding sides, they meet there, there, and there. Now, of course, I could interpret it this way and have this as the centre of projection, and then this triangle projects into that one, and here's where corresponding sides meet, and so on. There you've got, if you like, in the heavens, 10 stars in 10 lines of 3. I wonder if somewhere in the universe God has placed that. Well, we might find out one day. Here's another result. This one's simpler. This was attributed to Pappus, 2nd century AD. 2 lines, any 3 points on the top one, any 3 points on the bottom one. Join the first one on the top line to the second and third on the bottom, the second to the first and third, and the third at the top to the first and second. And where they meet at X, Y, Z will always be a straight line. How did all of these things just come about by chance? And the more I think of it, the more I think God is the great geometer. Gauss said that. Gauss was one of the famous mathematicians of the 1800s. Okay. Wow. Now this one, I'll promise you this is the last one we'll take that takes you a bit beyond what most of you have come up with. But here you have E, which is the base of Napierian logarithms. You have I, which is the square root of -1. You have pi, which is the ratio between the circumference and diameter of circles. You have plus, which is the additive symbol. You have 1, which is called the multiplicative identity, because whenever you multiply anything by 1, it doesn't change. You've got the equality sign, and you've got 0, which is the additive identity. When you add 0 to anything, it doesn't change. Now, I'm sorry about all of that. But people have said that this is a masterpiece of mathematics. This Euler came up with this, and I quoted him earlier. He was the one who said that it was a window into God's mind. I better start stopping. A window into God's mind. Incidentally, Euler was a Christian. I think from memory he was a Calvinist. He lost the use of an eye. And do you know what he said? I'll now have fewer distractions. Yeah. All right. Plato said God geometrises, Gauss, God arithmetises. Let me kind of wrap up now. Earth is just right for life. It's in the habitable zone for liquid water. If it was closer to the sun, it'd boil, produce steam. If it was further away, it'd go to ice. It has a protective atmosphere. It has a magnetic field blocking solar radiation. It has the essential chemical building blocks of carbon, hydrogen, oxygen and nitrogen. It has a moderate gravity. Too strong, we'd be glued to the Earth. Too weak, we'd probably fly off. Has a stable sun. Has a large moon, stabilising tilt. It has all the gases necessary for life in the right mixture. Oxygen is just in the right mixture for us. Its orbit is almost circular at about a constant distance from the sun, which means we don't get tremendous extremes of heat and cold. Its axis is tilted at just the right angle to expose a larger fraction of its surface to the sun. It rotates at just the right speed. And so it's a complex system of interacting processes that all work together. And so, yes, by faith, we understand that the worlds were framed by the Word of God. But God challenges us what? To lift up our eyes and see the one who's created all these things. And we can, with the psalmist, say, "O Lord, how manifold are your works. In wisdom you've made them all." And we're called to worship him who made heaven and earth, the sea and the springs of water. Paul exclaims, "Oh, the depths of the riches, both of the knowledge and wisdom of God." And we are told that in the future, if we're faithful, all the treasures of the universe will be open to the study of God's redeemed. And I want to be among one of those, and I'm sure you do too. And I'm sure we'll discover a lot more about mathematics. Thank you. Now I've got to hand over to you.
Thank you, Neville. I'll pray for Sven in just a moment, but let me first mention this topic. Sven's topic, finding exoplanets and the possibility of intelligent life in space. This is very much a topic for the 21st century. There was some work in trying to look into this issue in the 20th century, but enormous strides have been made in the 21st century into this area, and I really look forward to hearing what Sven has to say, what he has learned about what we can know. Trying to observe tiny little specks in terrible astronomical distances that there are there. Let's pray, and Sven will come up and he will share his presentation, Finding Exoplanets and the Possibility of Intelligent Life in Space. Our Father in heaven, thank you so much for the beauty that you have made and the way that you have put order and structure in the universe. And Lord, I pray that you'd be with us as we hear from Sven about life, life in the universe and other worlds in the universe. Lord, I pray that you would give us open minds to hear and to consider and to be ready to respond. I pray this in Jesus' name. Amen. Thanks, Sven.
Well, wasn't that a great presentation by Neville? Just to look at all of the mathematics, and it's. I remember when I was both high school and university, one of my favourite subjects was mathematics. So it was good to be able to just dive into that once again. Don't we live on a beautiful home? Would you agree with me? It's an amazing, amazing home here. Recently, there was the rocket Artemis 2 that went up, and their goal was to fly around the moon with the future goal of having another Artemis 3 mission to actually land on the moon itself. But for some reason, there's this kind of pull to not just look at the moon, but to also to look back at the Earth. And so Artemis, they turned back and they took this photo, "Hello World." Amazing shot. You have to try and figure out where on the planet it is, but if you can tilt your head, you might be able to figure it out. If I was to kind of rotate into something a little bit more familiar, Apollo 17 took a very, very famous shot, and this is called the Blue Marble, where you can see the African continent very, very clearly. But it's a gorgeous, gorgeous Earth. You'd have to agree with me, right? It is absolutely, absolutely amazing. Artemis 2, they went around the moon, and one of the things, if you are traveling around the moon, as you come over the surface, you'll see the Earth rise or the Earth set. And this is their picture of it. This was one of the lunar reconnaissance vehicles, and when it was on the surface, it took another picture of our planet as well. Just absolutely, absolutely gorgeous. And this was another Artemis shot when they're coming further out around the Earth. But it seems that every vehicle that goes out into space, they want to take a picture of our beautiful planet. This was the Galileo spacecraft, and they turned it round to take this shot of the Earth with the moon at the back. Half of the Earth, half of the moon as well. There's another vehicle that they sent way, way, way out to the very edges of the solar system, and that vehicle was the Voyager spacecraft. And it gets to the point where you can no longer communicate with these vehicles because they're so far out, you lose the signal. And so when the people who were controlling it, the technicians, the engineers, were controlling it, and they realized that it was going to leave their ability to communicate with it, they turned it round and they took this very shot here, which is actually rays of sunshine. But as they looked more and more closely, they discovered something which was amazing, and that was this. If you look more closely, you can see a very, very small dot. I'm not sure if anybody can actually see it. Can you spot it? Yes, you can. And this is that spot right there. And that, my friends, is where you and I are. We're sitting somewhere on that blue dot, that pale blue dot. Kind of makes you look rather insignificant, doesn't it? And Carl Sagan, an atheist, he actually wrote about this, very powerful words. Look again at that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you've ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors so that in glory and triumph, they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds, our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. He wasn't a Christian, he was an atheist. The Earth is the only world we've known so far to harbour life. There's nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. Would you agree with him? Some things you might not, but so much is true. You know, all of the blood being shed. You know, the reality is, my friends, that when we look at this world, it's the only world that we've called home. The only world that we know where there's intelligent life. But of course, my friends, there's other exciting places as well, right? There's other planets in our solar system. And I just wanted to go through with you. These planets are really, really cool. This is Mercury, right up near the sun. Its temperatures are extremely hot because it's so close. Because it's got no atmosphere, it's really cold at night. So daytime, 430 degrees. Anybody wanted to go there? Nighttime, negative 180. It zips around the sun at 88 days in orbit to go all the way around the sun. This is Venus. It's called our evil twin. It's the brightest object in the sky, other than the sun and our moon. The third brightest, I should say. And it's actually very interesting. It's similar to Earth. It's got this atmosphere as well. And one of the things that this atmosphere means is it's actually hotter than Mercury. So daytime, 467 degrees. So you get to choose if you want to go to Venus. And when you go right down to the surface, down underneath the atmospheric pressure is 93 times our atmospheric pressure here on Earth. Here you have Earth, and NASA provides this watch. You can watch all the satellites and things, and it's the fifth largest planet in the solar system. Only planet with water, and it's the only planet that's name is not from Greek or Roman mythology. It's actually a German name. You've got Mars, the only place that we've sent rovers to wander around and have a look at Mars, and we're hoping to get there sometime in the future, if money and energy allows us to. And here we've got Jupiter. Amazing planet, isn't it? Amazing. So the Jupiter has an atmosphere of primarily hydrogen and helium, and all those stripes are actually clouds of water and clouds of ammonia. And the big circle there, that circle there, is actually a storm that has been going for over 200 years, hundreds of years. That storm has been going. Then we've got our good friend Saturn with its beautiful, beautiful rings. And it has 274 moons. Amazing. 274 moons. And there's one moon, Enceladus, which has jets of water coming up. It's a lot of ice and jets of water. And then the moon Titan has these lakes of methane. Incredible planet. And this one is Uranus. Very, very cold and very, very windy. And our planet turns like that, whereas Uranus is kind of on its side, and it's turning around like a rolling ball. And then finally Neptune, so far out that when it's the middle of the day there, the sun looks as dark as it would be here at twilight. It's only just completed its first 165-year orbit around the sun from when we first observed it, or figured out that it was there. Neptune, amazing planet. But you know, the fact is that we look out at the sky, we see all these planets, but we wonder, is there any intelligence out there in the rest of the universe? We haven't found any intelligence except for on our planet. What about out there in space. And this has been a search for a long, long time. The search for extraterrestrial intelligence. And what they have done in the past is they have been turning their radio telescopes up out to space and just listening, just scanning the sky, sort of listening for signals where there's any pattern or coded symbols to try, or signals, I should say, to try and identify, okay, is that an intelligent being somewhere out in space that's sending back these signals to us? But of course, the sky is very large. It's very difficult to know where to aim and what to listen for, and is it an intelligent signal or is it not? And yet, this recently, just over 30 years ago, we made an incredible discovery. And I'm just going to play this video, and we'll just turn up the audio so we can get this going here.
At our hearts, we are seekers, observing stars and searching distant skies, looking for something familiar. And 3 decades ago, a remarkable signal cut through the cosmic dark. The discovery of the first planet beyond our solar system orbiting a star like our own. And soon there was not just one discovery, but thousands. As our curiosity for what is out there has grown, so has our science. We are discovering a greater diversity of exoplanets than ever before. Some ablaze, others frozen solid. A few changing the way we see our own solar system. But there's one we haven't found. A planet just like ours. At least, not yet. Is Earth the only home for life? Or are there other habitable worlds waiting to be found? With every planet we discover, we get closer to answering that question. We're entering the next great chapter of exploration, discovering worlds beyond our imagination, to look for planets that could support life, to find our cosmic neighbors, and to remind us that the universe still holds worlds waiting to be found.
Okay, so how did they find them? This is the amazing question. And it was these two Swiss astronomers, Michel Mayer and Didier Queloz, and back in 1995, they said this mysterious signal. Well, let me tell you exactly how they did it. They were watching this star, 51 Pegasus, and what they noticed is that the star wobbled. And they're going like, I mean, do you expect a star to wobble? You know, you'd expect the star to be absolutely rock solid and all of the planets going around it, or whatever. But they're going like, why is this star wobbling? Why is there a wobble? And let me explain to you what happened. So this was the star itself, and they actually saw the star wobble. And let me show you why it happens. Because as the planet goes round the sun, the gravity pulls both of them, not just the planet itself. And so you can see the star wobbling right there. And when the star comes closer, it's a blue shifted, the light, and when it's moving away, it's red shifted. So they saw this star. You can't necessarily see the planet as easily, but what you can see is the star and its wobble. And so it's exactly this. This is the planet right here. It was the 51 Pegasus B. And the idea behind this is similar to the hammer throw. You know those in the Olympics? So if you've got the hammer, the ball out there, and the Olympiad is trying to get faster and faster. So the ball is going round and round, but the actual athlete themselves is going in a circle as well, a tighter circle, and the ball is going in a larger circle. So what they measured is, so you can see this diagram here, when the star comes towards the Earth, it's blue shifted. When it goes away, it's red shifted, as the planet is going round that sun. So they measured this wobble in the star, and based on the measurement, the size of the measurement, how high it is and how far it is, they can work out how big the planet is in its orbit as well. It's amazing. And for that, they got the Nobel Prize in Physics. It's discovering the first exoplanet out in space. And since then, they have discovered many other ways to work out how an exoplanet is there, and they have discovered many exoplanets as well. That's one way to measure the wobble. There's another way, which is the transit measure, and I'll just show you how this one works. And this one works because when a planet passes in front of a star, it actually makes it go slightly dark. It's like a partial eclipse. So when it comes in, it darkens the star, and then it goes round, and the star is back to its full brightness. So you can see the process right here. So depending on how long the dip is and how deep the dip is, they can work out how big the star is and its orbit as well. This has been amazing. They've found many, many exoplanets through these and other methods as well. This is Kepler 1649c. And this exoplanet is really, really incredible because it's the same size as our Earth, and it's also in the habitable zone of the planet, of the solar system it's in as well. It's orbiting a host red dwarf star. So there you go. That's comparing the size of those two planets. And this is an artist's impression of what it would look like if you're actually on the planet itself. Now, I just have to say that all of these pictures of the planets are all just artist impressions, not AI, I don't think, but they are artist impressions. You cannot actually photograph these planets because they're so far away and they don't emit light themselves. But these planets are amazing. So this is Archean Earth, the only alien planet that we have geochemical data for. This is the new GJ 504b, and it weighs, if you were to put it on scales, fairly big scales, it weighs 4 times Jupiter's mass, which is the smallest planet that we've been able to image directly around the star. This is the HR 8799b exoplanet, and it's young, very hot. So if you didn't like Mercury and Venus because they were too hot, this planet's sitting at 815 degrees Celsius. So it's slightly larger than Jupiter and probably 7 times more weight than Jupiter. This one is the super-Earth exoplanet, 55 Cancri E, and it has an atmosphere which is thicker than Earth, but its planet is so close to the face of the star that it's consistently on the same face, a bit like the moon for us. This is WASP 18b, and it is located 325 light years away from the Earth, 10 times more heavier than Jupiter, and it goes around the sun every 23 hours. It is zipping around or not our sun, its star every 23 hours. Its atmosphere has carbon dioxide, but no sign of water. And this is one of the youngest planets that we've found. This is K2-33b. They love their numbers and their letters, don't they? It's the youngest planet, and it completes an orbit every 55 days. And so we found over 6,000 of them now. Amazing. This is one of over the last few years, over the last 30 years, finding exoplanets has been one of the great discoveries in astronomy. And here's some of the planets in Kepler system compared to our solar system. If you want to know how they're found or the method, this is a graph. So there was a huge spike in about 2017. They found so many planets, exoplanets. But you'll see that most of them are found by the purple, the transit method, which is that method where the planet passes in front of the star and it slightly darkens and then brightens up again. The other one, which is the radial velocity, which is the wobble, is also very high with that green as well. But literally thousands of planets. And what are they really looking for? They're not just wanting to find rocky and gaseous planets, I should say. They're trying to find planets where there could be intelligent life. Is that right? Or living beings, life itself. And one of the keys, there's a number of things they need to look for, but most important, they need to find planets that are in the habitable zone, which is this Goldilocks region of space, kind of like a disk around the planet, the star, where if you're too close, like Mercury, it's too hot. But if you're too far out, like Neptune, it's too cold. What you want to be is in that green zone, just flying around, where it's warm enough for the water to be liquid, but not too hot so it burns or evaporates. Interestingly enough, we have 3 planets in our inhabitable zone, or habitable zone in our solar system. It is Venus, Earth, and Mercury. But only Earth has water, and liquid water is that, and intelligent life, which tells us that the fact that a planet is in the habitable zone doesn't mean that there is necessarily life. It's a possibility, but it's not necessarily life itself. It's an amazing, amazing find. The question, though, is this. We still have no signal of any intelligent life, whether it's through SETI, the search for extraterrestrial intelligence, or even from exoplanets yet. Does intelligent life, intelligent beings exist in the rest of the universe? And the amazing thing is this. There is a signal, a faint signal, and it's found in the Bible. Because in the book of Job, it says this, "Where were you when I laid the foundation of the earth?" This is God talking to Job. "Where were you when the morning stars sang together and all the sons of God shouted for joy?" Do you realize this? That this verse is this faint, this illusion, this possibility of life in the rest of the universe. And one of my colleagues, who is the Old Testament lecturer at Avondale University, said, the interesting thing is that combining, so this is parallel, when the morning stars sang together and all the sons of God shouted for joy, it's a parallelism in Hebrew. And by saying that the sons of God are in parallel to morning stars, actually suggests that these are intelligent beings on other planets. Is this possible? Is it possible? You know, C.S. Lewis was an imaginative guy, a bit like Einstein. And he liked to write, is that right? He liked to write Chronicles of Narnia. But a lesser-known series of his books was called the Space Trilogy. First one was Out of the Silent Planet, where a Dr. Ransom was taken to Mars. Then his sequel, Perilandra, was when the Dr. Ransom was taken to Venus. And then finally, that hideous strength, he's back on Earth as well. For some reason, we have this kind of desire, this hunger to know if there's intelligent life. We want to know. We can't be alone in this universe, all by ourselves. And C.S. Lewis made this comment, or in the book Mere Christianity that Dr. John Ashton referred to earlier, he identified the logic of the argument from desire. And he put it this way: creatures are not born with desires unless satisfaction for these desires exist. A baby feels hunger, well, there's such a thing as food. A duckling wants to swim, well, there's such a thing as water. Men and women feel sexual desire, well, there's such a thing as sex. If I find in myself a desire which no experience in this world can satisfy, the most probable explanation is that I was made for another world. Now, don't get me wrong. This argument here, of course, is talking about God and heaven. I was made for another world. But it also, in a smaller way, actually suggests that our hunger for intelligence, even on other planets, could be actually realized as well. And I want to share with you, right here in the Seventh-day Adventist Church here in Lismore, that we have a record of visiting these planets. You realize that? We actually have a record of visiting these planets. In the book Early Writings, the young Alan White, or Alan Gould Harmond, records this experience. The Lord was given me a view of other worlds. Wings were given me, and an angel attended me from the city to a place that was bright and glorious. The grass of the place was living green, and the birds there warbled a sweet song. The inhabitants of the place were of all sizes. They were noble, majestic, and lovely. They bore the express image of Jesus, and their countenance beamed with holy joy, expressive of the freedom and happiness of that place. And so she goes up to one of these inhabitants of another world, and she says, I asked one of them why they were so much more lovely than those on earth. The reply was, we've lived in strict obedience to the commandments of God and have not fallen by disobedience like those on the earth. Then I saw two trees. One looked much like the tree of life in the city. The fruit of both looked beautiful, but of one they could not eat. They had power to eat of both, but were forbidden to eat of one. Then my attending angel said to me, none in this place have tasted of the forbidden tree, but if they should eat, they would fall. Then I was taken to a world which had 7 moons. And then she just loves this experience in early writings. And she goes up to her angel, the angel who is her tour guide. And she says, I begged of my attending angel to let me remain in that place. I could not bear the thought of coming back to this dark world again. Then the angel said, you must go back. And if you're faithful, you with the 144,000 shall have the privilege of visiting all the worlds and viewing the handiwork of God. Amazing experience, is it not? Amazing experience. Now, some of you might be saying, well, that's early writings. That's when, Alan White or Alan Gould Harmond was young and impressionable. Experiences, it could have been a bit of, Northeast American pizza or, the spaghetti that she had the night before. But I want to share with you that this was a theme which occurred right through her writings, including her most important ones as well. The Great Controversy. It says God's government included not only inhabitants of heaven, but of all the worlds that he had created. And Satan thought that if he could carry the angels of heaven with him in rebellion, he could carry also the other worlds. In Desire of Ages, when Jesus is on the cross, heading to the cross, it says this, all heaven and the unfallen worlds had been witnesses to the controversy. With what intense interest did they follow the closing scenes of the conflict? It was not angels watching Jesus die on the cross, but also inhabitants of the unfallen worlds. And the book Education, for those of us who are involved in education, it says the science of redemption is the science of all sciences. The science that is the study of the angels and of all the intelligence of the unfallen worlds. They want to learn about the salvation that you and I have the opportunity to choose. And this afternoon, I want to give you share that same message that the angel shared with Alan White, and that is, you might be looking at this going like, wow, this is amazing. How can we go back to our regular lives on Monday and Tuesday morning? And I want to say to you, as John Ashton shared with us this morning, if you choose Jesus, if you take one of those response cards that you have on your seats and you say, yes, I'd like to learn more about Jesus. I would like to even commit my life to him. If you put your trust in him, you could be part of that group of people who are ready when he comes back. The Bible symbolically calls that group the 144,000. And when Jesus does come back, he will take us on an incredible tour of all those worlds. My invitation for you is, let's go. Let's go.
Thank you, Sven. Now, our final of our three speakers, John. I invite him to come up in just a moment. I'll say a prayer for him. But he's going to be speaking on a topic which maybe some of you may think, what has this got to do with science? Unwrapping the Pharaohs. But this Faith and Science conference, at least from my perspective, is not just about the physical sciences or the sciences of trying to observe, experiment, use test tubes, those kinds of sciences. But also things like archaeology and the study of human history. Because at the end of the day, when we're talking about faith and science, trying to harmonize them together, the history of the earth is really what we're talking about, whether it's the distant history or the recent history. And I know I've already got some questions relating to history. What questions we don't get to this afternoon may be addressed tomorrow, but I think hopefully we've got enough time we can get through most of the questions, but no pressure, John. Give us your full presentation. Let's say a prayer for John before he begins. Our Father in heaven, thank you so much that you've given us insights from your word, that your word is true and that it is righteous altogether. And Lord, I pray that you would speak through John as he explains a different way of reading history that might help it to be clearer, might help your word to be clearer, and might help our understanding of where we've come from to be clearer. Lord, I pray that your Spirit would guide us and teach us, and that we would be prepared to have the conversations that may be difficult with friends, with work colleagues, with those with whom we wish to witness. And Lord, I pray that you would do this by your power and for your glory. In Jesus' name, amen.
Hello everyone. Now this is a topic that I've been asked to speak on, and a little bit of the background here. I did bring along some books. They're out in the car. Part of I've written. When I became interested in witnessing, and witnessing through writing, so I had the opportunity to write quite a few books in the area related to university stuff, environmental stuff, health and so forth, university textbooks. And so I thought one of the things that we haven't talked about a real lot is, well, Sven actually referred to it earlier, is this mechanical worldview or naturalism that this world or this universe is all that it exists, right? So there's no spiritual dimension, there's no God outside the universe, there's no angels, there's no supernatural. And so I put out a book called The Seventh Millennium. And what I did was called, and subtitled, The Evidence We Can Know the Future. And the idea there was I looked at all the examples, or not all the examples, but I looked at examples recorded down through history where people had premonitions that, oh yeah, they're brought in. So we'll put some of the books down the back. Maybe, Kevin, if you could bring up Unwrapping the Pharaohs, and we'll leave the other ones down there people can have a look at. And thanks very much. And so I looked up where accounts where people had had premonitions. Remember Pilate's wife warned him, don't have anything to do with that man today. Julius Caesar's, thanks very much, wife warned him not to go to the forum. There are a lot of examples like this. People had premonitions about the Titanic, the Aberfan mine disaster, lots of things like this. We have the prophecies, of course, of Daniel and other prophecies in the Bible. So I put these together, and that book was published by a secular publisher. And about that time, I thought, right, I should do some research and write on the evidence for creation. And I was at went down, the Answers in Genesis group had a bookshop at Epping. And I went down there one day and was talking to the person there, seeing what books they had on evidence for creation. And a voice from out the back said, oh, I know that voice. And this guy came out, I forget his name now, but I'd met him at a few of the Answers in Genesis and which later became Creation Ministries talks. And he said, John, we recently put a talk on at Macquarie University where we're putting up the evidence for a young Earth and six-day creation. And I've just forgotten the name of the guy now. Dr. Arthur Ritchie, was it? Dr. Ritchie? Well, anyway, the curator of the Sydney Museum at the time had stood up at question time and said, look, I don't believe that any practicing scientist with a PhD would believe in a literal six-day creation. And he said, I hope you don't mind, we mentioned such and such at the Atomic Energy Commission, and we mentioned you at Sanitarium Research. I said, no, I'm happy to witness for my Lord. And as I was going on my walks, go on walks and meditate and pray, and I thought, well, why don't I write to scientists who have PhDs why they choose to believe in creation? And that became the book In 6 Days. I should have had, anyway, there's a copy down the back there. It's free online. And that's become a bestseller. And for more than a quarter of a century now. Oh, yeah, thanks, Kevin. Bring that one up as well. So that was Richard Dawkins, the atheist and strong proponent of evolution. So that's the book of In 6 Days. Some of you might have seen it. It's actually free on the internet. If you go to creation.com and then typed in the search engine In 6 Days and John Ashton or In 6 Days preface, the whole book will come up and you just click on the names and they're the testimonies of the 50 scientists. So Richard Dawkins wrote a review and he said, these guys are going to believe in creation because they've been educated in church-based universities. Well, that was a bit of an exaggeration. I checked and only 20 of the 50 had been educated in 10 of the 50 had been educated in church-based universities, so only 20%. So what I thought, okay, if that's a problem, I will write to scientists who have been educated in state universities and taught in state universities and ask them why they choose to believe in God, the literal resurrection of Jesus Christ, the miracles of the Bible. And that became the book, The God Factor, that again was published by HarperCollins, major worldwide publisher. And later it's still available under the title On the Seventh Day, because the later publisher wanted a sequel. And so you can't make everybody happy, right? So somebody said, well, you've got engineers talking about why they believe in, biology, the creation and so forth. What about people who are qualified in the particular area? Okay, let's go there, let's have a look. So that became the book, The Big Argument, right? And I'm doing a series of that at the moment. You can watch them if you go on to YouTube, so you Google YouTube, so you go into YouTube, and then when you're on YouTube, you do a search, Creation Conversations. And actually we could, I'll do it tomorrow. I'll give out some cards with links to that. But I'm actually going through the chapters in that book. So what I did was I wrote to experts in their fields, right? again, all with doctorates, to comment on these particular questions. And one of the issues that I couldn't get anyone to write on with a doctorate was evidence for the Exodus. And this was very interesting. So in the end, a friend had mentioned, well, what about David Down? And he doesn't have a doctorate, but he'd done some work on that. And so he had a lot of work, and he wrote an article for me in the book called Unwrapping the Pharaohs. I only have one copy of that, actually, so I didn't bring it in case I lost it. But he said, I've been working on a chapter on the Pharaohs. But he said, I can't get a publisher. And I said, oh, well, I might be able to help you. And so I had a look through, and I said, this is brilliant, but we need a timeline. And he said, well, no one's done a timeline. And I said, well, we can do a timeline. I'm sure we can work out a timeline. So he mainly worked on it, and that became this book, Unwrapping the Pharaohs. And it's the first book that publishes a timeline of Egyptian history that matches the Bible account. Now, a number of detractors, the book initially was taken up by Creation Ministries, but then a guy, Patrick Clark, said, well, hang on, you've got some of Velikovsky's ideas in here. Velikovsky was a friend of Einstein, atheistic Jew, had some interesting ideas about Egyptian history that a lot of people dispute, and some of our ideas concur with some of his ideas as well. So that sort of decredited us. Answers in Genesis carry it. But despite all our detractors, like Patrick Clark and so forth, no one's come up with a better solution. And this I find is interesting. So let's have a look. So there's the major problem is this, that who was the Queen of Sheba? Okay? So that's one problem. Visited Solomon. And who was the Pharaoh, for example, who rescued Moses? So if you look up most Bible commentaries, who will they say was the Pharaoh or the daughter of Pharaoh who rescued Moses? Hatshepsut, right? Hatshepsut. So Hatshepsut was followed by Thutmose III, and where's Hatshepsut's temple? In the Valley of the Kings. And the Valley of the Kings is 650k or thereabouts south of Cairo and where the Israelites were, right? So the Israelites were working up on Lower Egypt, up near the Mediterranean end, the Nile Delta, right? The Valley of the Kings, Hatshepsut, Thutmose III, Amenhotep II, they're all down the bottom, right? We know so much about Thutmose III, what he did, all his he kept great records there. And also his son Amenhotep II. And their mummies are in the Cairo Museum. Their mummies aren't, they're not missing. So what they say is Hatshepsut was the daughter of Pharaoh that rescued Moses. Thutmose III was the Pharaoh of the oppression. His son Amenhotep II was the Pharaoh of the Exodus. But so you now have, for example, you go on Creation Ministries, they will argue, well, maybe the Pharaoh didn't die. So he actually didn't go in the Red Sea. He didn't die. It was only part of his army that was destroyed. All this sort of thing, which is a little bit different to when you actually read in Exodus chapter 13, through that chapter there, God's making an example of destroying. So it doesn't fit. And that's one of the reasons we know so much about the 18th dynasty, which is Thutmose III, Hatshepsut and so forth, that the secular scholars say there's no evidence of Israelite slaves there. It just doesn't fit. There's no record in their evidence there of the plagues or anything like that. But there are clues, so let's have a look at those. Okay, this one, is this the right one or is this one? That's yours. How can I make this work? Is this going to work? Oh, it did. Okay, I pressed my own button. There you go. Okay, so let's have a look at some clues, right? This is what we've got to do. So for the date of the Exodus, let's start with that. 1 Kings 6:1 says that the 4th year of the King of Solomon's reign, which is about 965 BC. Now I'm happy to use Wikipedia, right, because they're summarising whatever most people accept as the best secular evidence, right? So let's go with the secular evidence, because people aren't going to pick us up on that. Was 480 years after the Israelites left Egypt, right? So this means that the Exodus occurred about 1445 BC. Now, the dates for King Solomon's reign are a bit rubbery. For example, Usher has it about 1000 BC or maybe 1004 BC. And that gives him an older date for creation as well. So there's 40 years, 50 years maybe. So they're a bit rubbery. We can't pin them down exactly, but there's pretty good evidence that that's about right, 650 BC or 665 BC. So that's when the Exodus occurred. Let's look at round figures, we don't want to be too pedantic because we don't know exactly, but at least we're going to be in the ballpark, within a few decades of being right. So we've got 1445 BC. So the dates for the Israelites leaving Egypt is not consistent with the history of Egypt for that time. Just doesn't fit. So that's why secular scholars write off the Exodus. And that's probably the reason why not even any Adventist archaeologists would do an article for me. I couldn't get any Christian archaeologist with a PhD to step out and do that. So let's have a look. And just Google Wikipedia, the Exodus, right? The above article claims there is no direct evidence for any of the people or the events of the Exodus in non-biblical ancient texts or in archaeological remains, and this has led most scholars to omit the Exodus events from the comprehensive histories of Israel. That's where we're at, and that's why people rubbish. That's why people rubbish the story, and probably one of the reasons why Einstein gave up on the Bible, and probably other people as well, and possibly why some theologians too, once they study theology in some of the more critical, higher criticism schools like Princeton and so forth. One of the problems we have is that the conventional dates for the 18th dynasty are as up on the screen there. So you've got Thutmose I, was Atmosis was his dad, I think, who was the first founder of the 18th dynasty, but Thutmose I, he certainly did a lot of conquering. There's Thutmose II, then there's Hatshepsut, and then there's Thutmose III. He was the greatest of the Egyptian pharaohs. He's called the Napoleon of Egypt. He was a military genius. So we know so much about him. And then Amenhotep II, and then we've got Thutmose IV, Amenhotep III. So what happens is, right, if the Exodus occurred at that time, during Amenhotep II, wiping out Egypt, how can it be the golden age of Egypt? How can it be an area where they had immense wealth and peace and were constructing all these monuments? It doesn't fit. Right? So you can see, so what's the solution to this? Well, because these dates correspond to the biblical Exodus time, we've got to make a choice. The Bible commentaries have Hatshepsut as the daughter of Pharaoh who rescued Moses, Thutmose III as the Pharaoh of the oppression, and Amenhotep II as the Pharaoh of the Exodus. But they don't fit with this historical data of these pharaohs does not fit with the Bible. So you've got to make a choice. The Bible or Egyptian history? And that's a tricky one. What one are we going to go with? Well, we've got a lot of record that the Bible's pretty right, okay? And there's a lot of people we know in the past that said, Belshazzar, there's no such record of Belshazzar, and then, the king who saw the writing on the wall, and then they find it. So many cases like this where they've argued the Bible is wrong, and then later we find the evidence. But this one is a tricky one. So there's a picture of Hatshepsut's temple in Luxor there. Valley of the Kings. a long way from where no Israelite slaves are not building with mud bricks. Doesn't fit. Here we go, the Annals of Tutmosis III. There's a big wall there where he outlines a history of a whole lot of his conquerings, right? There's a Karnak, way down south, not at Goshen, up where the Israelites were. There's a list of 119 Palestinian towns. So what are the Egyptian pharaohs doing running around over there? I thought they were all these other primitive Canaanites that they were conquered during his first campaigns. Another 240 names of cities between Lebanon and the Euphrates, which he took in the 33rd year of his reign. So you can see it's totally different history. They're well preserved, but the dates are disputed. So this is the weak point now we need to focus on. The problem is the dates with the Egyptian history, right? Because they didn't have a calendar system. And so were their kings reigning concurrently or are all of them successive, right? And this is where the problems come. And so we can see again that his son, Amenhotep II, he was a successful military leader. We know when he died. We've got his mummy. Both mummies are in the museums in Egypt there. There's no record of Israelite slaves. There's no record of building with mud, straw, bricks. They can't be the pharaohs of the Exodus. That's the bottom line. So the dates can't line up. But if we shorten secular Egyptian history by 450 years, the pharaohs of the 12th and the 13th dynasties fit the Exodus account really well. Now that's a long time, 4.5 centuries. But we're not the only people. David Roll wrote a book, Centuries of Darkness. There's quite a few scholars that challenge the date of the Egyptian, conventional dates. So let's have a look at the 12th dynasty. So we've got essentially Senusret or Sesostris, I prefer to use, that's the anglicised version. And one of the things when you're reading in studying Egyptian history, see the three names up there, Senusret, Sesostris and Senusret, the first, they're all the same guy, right? And different scholars will refer to him by different names. And I tell you what, when you're used to chemical molecules, that's a lot easier to remember than these Egyptian names where there might be just a W or an S or an extra S difference. And so he expanded Egypt and he ruled with prosperity, but he was in the territory of Egypt. Now he had an Egyptian official and treasurer named Mentuhotep, who was one of the best attested officials of the Middle Kingdom period. There's statues found of him, and he was given the title Overseer of all the royal works, and his description actually fits Genesis. Now these are descriptions, as I said, looking up Wikipedia, right? So Wikipedia is saying this. But Sesostris was succeeded by his son Amenhotep, Amenemhat, right? So not Amenhotep, Amenemhat. Man, I get mixed up with these. Whose pyramid used mud bricks. So did Sesostris' one. And he was succeeded by Senusret II, who also used mud bricks. But Senusret was not the legal son of Amenhotep II, Senusret II. And it's interesting that Josephus records that, so there was a change in family name as noted by Josephus, as that was the pharaoh who started the oppression. So here we find just a little interesting clue in Josephus' writing that there was a change in the family, and that was the pharaoh that began the oppression of the Israelites. So Senusret I, he was a goodie, supported Joseph, and they had this time of peace followed by his son, right, Amenhotep II. But during this time, the Israelites were increasing. And this again is recognised by secular scholars, that they had Asiatic slaves and that the slaves were increasing, right? So we look now at the Bible clues. Genesis 41, Joseph prepares Egypt for famine. A famine is recorded by one of Sesostris' officials. And Sesostris' treasure was Menhotep was bound down to in public. And it's interesting that one of the, Broschkes Bey, he was a German archaeologist who did a lot of work studying the 12th dynasty, translating a lot of their documents and inscriptions. And he published a book, Egypt Under the Pharaohs, and in page 158 and 162, this is what he records, that Menhotep was bound down to in public, and there was a severe famine there. If we read in Genesis 41, those verses there, Joseph was given Pharaoh's ring and rode on Pharaoh's second chariot. So this is the Bible record. The Bible record says that Joseph was given Pharaoh's ring and rode on a second chariot. Now, chariots were very rare at that time. They were like a modern invention. It was sort of like, cars in the early 1900s. And so this is just a little bit of a clue that fits the secular evidence. But we've got to remember that the 12th dynasty is placed much earlier, right? So the archaeologists don't connect it with the Bible account. The other thing is that Exodus 1:7 says, following the death of Joseph, the Israelite population grew mightily. So the Bible says that, right? We could look it up. I didn't bring my Bible up here with me. It's in my bag there. And again, if you look up Exodus 1:8 to 14, a new Pharaoh arose who started oppressing the Israelites. And this fits Sesostris II, because from the inscriptions, he was an extremely cruel guy. And you look just as his statues, he wasn't smiling. If you look at the statues of Sesostris I, he looks a really nice guy. If you look at the statues of Sesostris II, big change there. And Exodus 12 describes how late for the Exodus, the Israelites left in a hurry. And this fits evidence of excavations in Kahun, a town built for King Sesostris II, that was to house all the workers making the mud bricks for the pyramids. So here we have a town, the record of a town, 4 slaves for the builders that were building the pyramids out of mud bricks with straw, right, for this particular king, Sesostris II. And a lot of work was done on that by Rosalie David. Now, Sesostris III, that followed on, was among the few Egyptian kings that wanted to consider himself God, and he was also a very mean-looking character. And his pyramid is quite large, but it's built of a core of mud bricks. And they weren't made using moulds, they were all different sizes as well. So this is interesting, and this is all stuff from Wikipedia. But during this time in secular history notes that there was a large population of Asiatic slaves working in Egypt, and Genesis 46 explains that Jacob had took his family there. So we have from the Bible that Joseph took his family, 12 sons and their wives and kids. They went across and then they grew very rapidly. And so by this time, by Sesostris III, we had a very large population of slaves there, of Israelites working there. Now, Amenhotep III would have continued the oppression. He's portrayed again as a very powerful ruler, and he ruled for 45 years, which is interesting Again, his pyramid's core was constructed of mud brick, stabilised with limestone framework. And there was a lot of mud brick building going on there. So again, this is from Wikipedia telling me about these people, right? But he had no sons. He had 2 daughters, one of whom was Sebokneferu. And she was probably the Pharaoh that rescued Moses. So the link between Amenhotep III and his successor and Amenhotep IV is unclear, right? So we know that Sebokneferu had no children of her own, which was probably why she was down bathing in the river, worshipping the fertility god there, because she would have had a sumptuous bathroom at home. She wouldn't have had to have done that. She was down there for some ritual purpose. She's praying, and this little baby floats by, or one of them, no, not floats by, so one of her maidens notice a basket caught in the reed, she goes over, and he's adopted. Now this character Amenhotep IV is very interesting because there's no recorded link between him and Amenhotep III. So there's only speculation. We don't know much about Amenhotep IV. There's varying archaeological reports on him. But we know that Sobekneferu had no children. She was the daughter of Pharaoh. She ascended to the throne when Amenhotep IV died. She had no fear. Now, some people think Amenhotep IV may have been Moses. I don't know. We don't know, so we can't say one way or the other. I don't think so personally, but it's only a thought, right? Now, let's look at data. One thing we do know is that Sobekneferu had no children. She was replaced by Amenhotep IV. She had no heir. And because she had no heir, that was the end of the 12th dynasty. And a new dynasty took over, the 13th dynasty. Right? And what happened then, there was a bun fight, right, for the dynasty. And you had a whole series. There were 14 kings ruled in quick succession, some for a couple of weeks. And then someone else took over, right? So a whole lot of kings took over until Nefertitop I established some stability, and he ruled for 11 years. Now this is interesting. Nefertitop was the last pharaoh for which scarabs were found in Kahun before it was suddenly and inexplicably abandoned with tools, pottery and everything left behind. Now that's a quote again from Wikipedia. Now if we go independently, and I haven't put it up there, but Rosalie David was, I'm pretty sure she was from Oxford. She was a British archaeologist that did a whole lot of work around Kahun. And we talk about this in the book here, and there's pictures and everything that David Down took all through the illustrating the book there. If you want to read it, I don't have copies, but you can buy copies there. But one of the things that she found was, when she was exploring under these ruins, often under houses, she found these little boxes with baby skeletons in them. Lots of them. Matter of fact, she had one on display in her museum at Oxford. And what happened? They didn't pick it. Because they picked this as a different time to the Israelites, much earlier, 450 years earlier, they don't connect it. There's all these clues. They found the city there, Kahun, right, that built the pyramids out of mud bricks. It's suddenly abandoned. The guys people leave their tools, their possessions, their furniture, everything there, right? But they don't connect it with the Israelites because in their mind, no, it's too old. But it's interesting, Menenfo, and I mentioned him earlier, the Egyptian historian, 200 to 300 BC, during the Greek reign there, that Nefertitep I was the last king to rule before the Hyksos occupied Egypt without battle. And that's pretty significant, isn't it? Why could they occupy Hyksos without battle, and Egypt without battle? And the Hyksos were like the Vandals. They were sort of totally uncivilized, barbaric sort of people, race. But because the Egyptian army had been destroyed. How did they know the Egyptian army had been destroyed? Because remember, they hassled the Israelites, and they would have found out that Pharaoh's army had been destroyed from their interaction with the Israelites. So we have so much circumstantial evidence that just fits this picture. The other interesting thing is that we know from Exodus 14:28, Pharaoh and his army were at the bottom of the Red Sea. And I'd like to emphasise this. I'm just going to get my Bible about this and read it out, because let's have a look at our Bibles on these verses here, because this is something, and I'm really disappointed that creation ministries have tried to argue that they weren't destroyed. So let's have a look at it and read it for ourselves. And of course, I'm not an expert on Hebrew, but the guys that translated Bible, so I've got a Revised Standard Version here, but if you read a New American Standard Version, some of these, it's supposed to be the best scholarship that we've got, or using the best documents, right? And if we look in Exodus chapter 14 there, and we go down to verse 28, the waters returned and covered the chariots and the horsemen and all the host of Pharaoh that had followed them into the sea. Not so much as one of them remained. And Israel saw the great work which verse down 31, that the Lord did against the Egyptians, and the people feared the Lord. When we go over and to read a little bit earlier in Exodus 14 there, so I'll read from verse 5 of Exodus 14. When the king of Egypt was told the people had fled, the mind of Pharaoh and his servants was changed towards the people. They said, "What is this that we have done, that we have let Israel go from serving us?" So he made ready his chariot and took his army with him, and took 600 picked chariots and all the other chariots of Egypt, with officers over them all. And it goes on, the Lord hardened and the Egyptians pursued them, all the Pharaoh's horses and army, and encamped. We read down a little bit further. The people were afraid. And verse 17 is another interesting one. And reading here's God speaking, "I will harden the hearts of the Egyptians so that they shall go in after them, and I will get glory over Pharaoh and all his host, his chariots and all his horsemen. And the Egyptians shall know that I am the Lord. I have gotten glory over Pharaoh and his chariots and his horsemen." And so I think if you read through that chapter, to me anyway, it's pretty clear that that the Pharaoh was destroyed along with his army at that particular time. So you can read that and study that for yourself. The other thing is that the 13th dynasty initially ruled from the Nile Delta, and this and another quote from Wikipedia. This is what they say: "Ruled from the Nile Delta," that's where the Israelites were. "However, the dynasty is marked with a period of decline, instability, and the Hyksos dynasty taking control shortly after." So here's Wikipedia giving us a summary of the Bible account. So according to, and I'll just go a little bit back about the scarabs. So we have that Nefertitep scarab was the last scarab. So scarabs were little insignatures with the name of the current pharaoh, and they might have been worn on a bracelet, on different jewellery, commemorating that that's the king at that time, right? So what that finding is actually quite important. What it's saying is this, that in that town that was suddenly abandoned, they left it all, the last name of a ruling pharaoh that was found there was Nefertitep I, implying that he was the pharaoh at that time when the people suddenly left. Right, so we've got to read this data. It's quite significant there. So going on, now one of the things that they say is that, well, let me read it. According to the Tambo Stele of Thutmose III, when Thutmose led a campaign in Asia, okay, I've got my thoughts together again now. Okay, so we've got this powerful evidence that during the 12th and 13th dynasty, at fits the slaves then, right? And it's interesting, Nefertitep I's mummy has never been found, and there's no record of how he died. So again, that fits. Nefertitep I, look it up on Wikipedia. They don't know how he died, his mummy's never been found. And that again fits him dying and then not keeping any records after that. So that fits. But if we move the dates 450 years closer, it brings another alignment, because what that does is that aligns Hatshepsut as the pharaoh during the time of Solomon. And this is really interesting. Now, one of the arguments that used against that is, now remember, who did Solomon first marry? Daughter of Pharaoh. What did he give Solomon as a dowry? The town of Giza. Now, this is very interesting. Tutmos, what they say is that, so we know that Shishak came in when Rehoboam followed Solomon, right? He didn't listen to the wise men. Kingdom was torn away. And Shishak came in and looted the palace and the temple and took away all the gold shields, right? And all the gold, right, out of the temple there. And so who is Shishak, right? You Google Shishak and they say it was Pharaoh Shoshenq, okay? And this is what creation ministries go, and so that's why they argue that, Hatshepsut must have been the daughter of Pharaoh, because they have Shoshenq in, as the line-up with Shishak. But it's very interesting, if you Google, did Thutmose I conquer Giza? They say no, that Giza was conquered by Thutmose III. But it's very interesting that when you dig deeper into some of the records, you find that there was a campaign that Thutmose had, and he actually captured Giza. But the AI doesn't pick it up, but I'll give you the references. So according to the Tombo Stele of Thutmose III, when Thutmose led a campaign into Asia, all the way to the Euphrates, he found no one who fought against him, right? So he wasn't oppressed. So this is going back a little bit further. This is before the time of Solomon. Also, for example, the fiery destruction of the stratum 18 of Giza has been assigned to the second half of the 16th century BC, the time of Amenhotep I and Thutmose I, based on the pottery and scarabs discovered. So what they're saying is that at Giza they found the scarabs of Thutmose III. And there's the quote for that, from that scholar there, published that work published in 1981 in the Bulletin of the American Schools of Oriental Research. And it's interesting that 1 Kings 9 verse 16, and this is a quote, says, "For Pharaoh, king of Egypt, had gone up and taken Giza and burnt it with fire and slain the Canaanites that dwell in the city and given it for a present unto his daughter, Solomon's wife." So that's a direct quote from the Bible, and that matches the translation from the Tombo Stele of Thutmose I. That's pretty powerful alignment there. So this means that Thutmose I, of course, was the was the father. He had two daughters, Hatshepsut and Nefertiti. Now, Nefertiti, her name means beauty of Lower Egypt. She is depicted with her parents, Thutmose I and his wife, Ahmose, in Hatshepsut's mortuary temple. But then she vanishes from Egyptian history. Why? She married Solomon. She would have been the daughter of the Pharaoh who married Solomon. Then Solomon formed a marriage alliance with Pharaoh, king of Egypt, and took Pharaoh's daughter. You read this. This is a quote from 1 Kings 3:1, right? So it's in the Bible. Then Solomon formed a marriage alliance with Pharaoh, king of Egypt, and took Pharaoh's daughter and brought her to the city of David until he had finished building his own house and the house of the Lord and the wall around Jerusalem. Now, if your sister had gone over to America and married a multi-millionaire, and she writes to you and she says, "Oh, you should see my glorious home," and you were her sister, what would you do? What would you do? You ladies, what would you want to do? Would you want to go and visit your sister? Of course you would. So that's what Hatshepsut would have done. It just fits so well. right? She would have visited her sister, and so it fits that Hatshepsut was the Queen of Sheba that visited Solomon. And you read all about it in 1 Kings 10, those verses there, 1 to 10, verse 13. One of the interesting things is that when you look at in Hatshepsut's temple that she built, there's engravings of this journey that she went. And she came back with all these goods, and no one knows from where she went. And her servants are carrying back all these different plants and apes in cages, right? And I think it's quite fascinating that you read there in... did I put the verse there, or is it in the next one? Anyway, it must be in verse 22. Yeah, verse 22. If you look in 1 Kings chapter 10, verse 22, it has listed Solomon kept all these sort of things. He's very interested in nature and different animals and plants and stuff, and he kept baboons. It's interesting the Bible mentions that, and he kept baboons. And in Hatshepsut, she's got servants carrying cages of animals that could be baboons. They're apes anyway. Now, what they argue is that the Queen of Sheba, so if you look at that Arabic peninsula there, the bottom part of it was an area called Sheba. And they say, no, it was just a queen from there that was up visiting Solomon, right? This is the standard thing. But Jesus referred to the Queen of Sheba as the Queen of the South. And in Daniel 11, the King of the South refers to Egypt, King of Egypt. And Josephus also records that it was the Queen of Egypt that visited Solomon. Right? So we don't know who the Queen of Sheba was, really, right? But we forget that Jesus called her the King of the South, and normally that was the King of Egypt, and Josephus also says that she came from Egypt. So these are two sources much closer to that time than our higher critics now. So I think there are so many clues there. You see, Hatshepsut was succeeded by Thutmose III, as we talked about, one of the greatest generals, and he fits the description of Shishak, looting Jerusalem, when you read about his excerpts. And there's articles there you can look up. And so Thutmose III looted Kadesh's surrounding lands and attacked the city during multiple campaigns. Now this is very interesting, and you can read the rest of it up there on the screen, that we know that Jerusalem itself wasn't attacked. The Egyptian army just went in and took, right, because the battle was out. But what was this Kadesh? And there's again an argument over Kadesh, and the non-believing scholars argue for all the different things. But it's quite interesting that the word Kadesh, and Sven would know a lot more about this, and maybe I'm wrong. I'm happy to be corrected on any of these things, right? Because this is certainly not my area, but I've stayed up late several nights looking at this stuff. Kadesh can mean the Holy Land or holy place, and was actually used as a name for Jerusalem as well. So that's very interesting. And I think of another slide on this, linguistic translation. The Hebrew word Kadesh translated as holy or sacred, and this is the exact root behind the modern Arabic name for Jerusalem of Al-Quds, the holy. And early lexicographers like Smith's Bible Dictionary note that the Semitic parallel, but it does not mean that biblical writers used the name interchangeably. So Wikipedia acknowledges it, that it can mean Jerusalem, but they say don't necessarily jump to that conclusion. So here we see that secular scholars have all this data, but they're very reluctant to admit that it lines up with the Bible so well. And there again, so this revisionist chronology, where we shorten the chronology by several centuries. This is a comment. Some fringe, non-traditional theories, most notably Immanuel Velikovsky supporters. Well, I'm not a Velikovsky supporter so much. I'm looking at evidence, right? Reinterpreted the ancient military campaigns lists such as those of Pharaoh Thutmose III. They argued that Kadesh captured in these texts actually referred to Jerusalem. Mainstream historians and archaeologists reject this. But they're only rejecting it, in my view, because they want to hold to a worldview that doesn't support the Bible as being right. So, if we reduce Egyptian history dates by 450 years, and I noticed there was an article published just recently where they've done, they've aligned some other volcano where they've dated using carbon-14 dating, that's showing that this volcano erupted before the time of Thutmose III. Therefore, Thutmose III must be after this. Therefore, the date for his age must be shortened quite a bit. So that's pushing it more in the favour of what we're alluding to. And I thought to myself, having done quite a bit of research on carbon-14 dating, and you look at the calibration curves, if you correct for the variation in the atmosphere, it's going to shorten that even further. And so really, we're starting to get more and more evidence that we need to shorten these dates. Yeah, and that was published just recently. Some German researchers found this. And I think they were German anyway. And there's a quote. What we find is that if we reduce the age by these years, we get remarkable alignment of the available clues with the Bible account. And so I think it's so sad that we, unfortunately, in our commentaries, we're clinging to Hatshepsut as the daughter of Pharaoh rescued Moses. It's not going to work. You know, the history isn't there. But if we go back to Sebokene-Pharaoh as the daughter of Pharaoh that rescued Moses, so much fits. You know, Nefertitep mummy hasn't been found. We go back further to Joseph time and Sesostris, right? We read in the Bible, just little clues, right? Little clues. Bible gives us just enough data points, right? So who did Joseph marry? Who did he marry? The daughter of the priest of On. Sesostris I was an On worshipper. Sesostris I's obelisk, I think, is in Paris somewhere, a massive obelisk that they've transported over there, and it's all dedicated to the worship of On. So this a little clue again that just fits. We've got the right alignment here, happening here. And there's, as I said, with Rosalie David's work that aligns with some of those German archaeologists and Briested and so forth. Because in there had this mindset that it's 400 years earlier, they just ignored it and they don't write it. If you change that and slide it forward, so much fits. And Hatshepsut fits for the queen that visited, Queen of Egypt that visited Solomon. The Nefertiti fits as the daughter of Pharaoh that marries her because Thutmose I had actually taken Giza. And as I said, if I do a Google search, did Thutmose I conquer Giza or capture Giza, it says no. But when you dig down to some of these research documents, you find, yes, he did capture that. So I think it's absolutely fascinating. Anyway, look, it's very complicated, and I guess if you found it hard to follow what I'm saying, I'm there with you too. I've got notes in front of me. But from what I can see, if I go to the secular archaeological history, I can find a whole lot of clues that match exactly the fine details, just little snippets of things that have been recorded in the Bible. And that gives me two things: that overall the big picture of the Bible account is true and accurate, and that it's divinely inspired, that God allowed for the people that wrote those things, like the people writing the Book of Kings, and Solomon kept apes, and the account in Genesis, and Joseph was given Pharaoh's ring and rode in a chariot. Just these little clues are just enough that we can line them up with history today to give us faith. So I hope that's been helpful and encouraging, that I believe we can truly believe the Exodus account as a real account, a real miracle of God. Thanks.
Thank you, John. Well, you might be feeling a little bit overwhelmed with all that information. And how many of you is this some new information today? All right, there's a lot of new information, but it's been very good. Thank you, John and Sven and Neville. In a moment, I'm going to ask you to come up, and we're going to put some seats here. And if it's all right, it's going to be live streamed, so don't say anything that you don't want to be freely available out there. But before we do that, there's a video, and while the video is being played, if you haven't already filled out the decision card, please do that. They're going to be, just put them in the offering, and you can tick. The first one says, I would like to join a Bible study. Second one is, I would like to be baptized and join this church. Third one is, I would like to support the Faith and Science Conference. So that's this one and also potentially future ones. And the fourth one is, I would like to be trained in witnessing through faith and science. So that may be as a speaker someday, but it may not be. It may be simply in your personal witnessing. This is just, if you put your name there and some contact detail, a phone number or some sort of email address, something like that, this just helps us to be able to know who we need to support and who is interested in being more involved in this kind of thing in the future. You've all come because you're interested in the topic. Maybe you're more interested now than you were. Maybe you're less interested. Either way, just let us know what would be helpful for you, and then we can help you. So yeah, if you play that video, and we'll take up the offering. All right, is everyone ready for some questions and answers? I've received a number of questions. We're going to get you mics. I think. Tim, do you mind? Yeah, bring them. So we have a few, and I don't know. We have about 15 minutes until 4:30. Is everyone who's happy to stay maybe a little bit longer to get through more questions? All right, so if we'll try to finish the I think the best questions first. No offense to the questions that come later. The first question is for John, and I wanted to do this first because it harkens all the way back to the talk right at the beginning of the day at breakfast, and I think I've understood it correctly. The question is why, when scientists create a peptide or amino acid, something like that, why is there a byproduct made, but when God creates, it doesn't? Does that make
okay. So that's probably referring to these molecules that that occur as mirror image molecules. So if you have like a carbon atom, which has a valency of 4, and you can put 4 different ligands on that, that will automatically have a possible combination where you can arrange those ligands as a mirror image of each other. So that's just a property of the stereochemistry. And what it happens is that when molecules combine, because in nature they're moving around randomly, they'll orientate, because they can combine chemically the same way but in a different structure, where one structure is a mirror image of the other, that will happen just randomly. And because there's so many reactions occurring, to make up a quantity, then you get up what we call a 50-50 mixture. That's just statistically that happened. It might be, 48 and 52, but it'll be very close to 50-50 just as a result. But in nature, what happens is that in a living system, God can arrange it so that molecules form in an existing framework, and so as the reaction occurs, it fits this pattern, and it only produces the one form. So that's just a property of living systems. It's very different. We can't replicate that in the laboratory. We can't. In the laboratory, if a racemic mixture is possible, we can't make the reaction just produce one type. It always produces 2. But in living systems, they're set up by God in such a way that they only produce the one type.
Wow, God is amazing. All right, thank you, John. Now, John, there are also a few questions relating to your sermon and talking about the ark. I'll pick one, and there's also one here that I think maybe Neville might be able to weigh in on as well. This is relating to the first part of the talk, where it was talking about Jesus and the empty tomb. I checked the Greek on that you were talking about the wrapping cloths. This is not the question, this is me. You were talking about the wrapping cloths, and I checked the Greek, and interestingly, it actually says in the Greek, the word for lying, the cloths lying on the tomb, can actually mean standing on the tomb or like sitting on the tomb. It's not sort of flopping down on, hanging off the table. So I thought that was very interesting. And it also mentions that the napkin was not like those other cloths. It was lying. It was flat. All right. So I did think that was very interesting. Thank you. But this question is, why did they have a string in the mouth of the tomb?
Yeah, just have to ask the funeral directors back then. I don't know.
Trade secret. Okay. All right. Maybe to stop people getting in and out. All right. And also maybe for John or maybe Neville might have a thought on this as well. Why is a rainbow why are the colours in a certain order, and why 42 degrees and 50 degrees? Neville, do you have thoughts on this?
Well, I think it's I think it's to do with the angle of the refraction, hasn't it? And so certain colours, and look, I did study it years ago, but I've forgotten about all of the exact details now. But obviously, some colours, what's the word that
red,
I'm
orange,
groping
yellow,
for?
green, blue, indigo, and violet.
Frequency, yeah.
Yeah, frequency, I think is the word.
Oh, frequency, yeah, just to do with frequency.
Will cause them to disperse, and those with lower frequencies will go to one side, and those with the other side.
Can I make a comment on this? Do you mind a story?
make a comment.
Because this switches me on, that the physics of the rainbow was only really worked out in the 1960s to explain that, and of course it's to do with the light travelling different distances over this curved surface, right? And so it separates the frequencies. So you've got the blue end of the spectrum and the red end of the spectrum in between. So it's anyway. But one of the other things is that there are different types of rainbows. So that's the rainbow caused by diffraction. But if you're flying up high, sometimes when you look out of a plane, you'll see a rainbow over the top of the clouds. You ever seen that? I remember flying from Hobart to Melbourne one day, and I saw the rainbow on top of the clouds, right? And I'll explain this. And I got really excited. I said to the lady next to me, I said, if you look out there, there's a pilot's bow. They're very rare. And she looked at me and she looked away. Anyway, the hostess was walking past. I said, you should tell the people on the left side of the plane, it's a pilot's bow. I said, yes, sir, that's all right. But it's very interesting because what causes a pilot's bow is very different. So what happens is on the top of clouds, you have very, very tiny water droplets, and the light actually doesn't pass through the droplet like it does in a rainbow. Instead, the photon of light skims around the surface of the light and then re-emits and interferes with itself, right? So the different colours form, as you've got a wave coming along this way and a wave coming out, they can partially cancel and change the frequency. So produce the colours. And so the range of colours depends on the range of actual droplet sizes. And that wasn't worked out till the early 1970s, but it led to a very interesting discovery. So what had happened, these bows, when the first explorers to South America went to the top of the mountains, they saw these rainbows, these beautiful coloured rainbows over the top, circular rainbows over the clouds. And a British physicist by the name of Wilson climbed to the top of Ben Nevis in Scotland, trying to see one and understand what happened. In order to try and understand it, he developed a cloud chamber where he artificially made clouds. And in order to seed the water droplets and produce clouds, he used a piece of radioactive material, and he saw all these heavy particles, and that led to the discovery of alpha particles, helium nuclei. Yeah, pretty exciting. Anyway, that turns me on, but anyway.
That's
and they're different. And so God must be surrounded by these beautiful colours all the time. Yeah, okay.
Yes,
cool.
God is surrounded by a rainbow. That's in Revelation, isn't it?
They're different to the water ones,
Yeah. Now, Sven, this question is for you, and it relates to your Sabbath school lesson. It might also relate to topics you're going to do tomorrow, but the person asking the question won't be here tomorrow. So if you could answer for us, please elaborate on the concept of God is timeless, and this making him impersonal. If God has no beginning or end, created time, space, and matter, does this not make him timeless?
Yeah, it's a very good question, and the idea is this. It's a couple of things that we need to think about. First of all, this idea of God creating time. So if God created time, the logic goes, well, he is outside of time. He is timeless. The second kind of reason to follow this would be the whole idea of God's foreknowledge. And I was thinking about this. How does God know in the future what is going to happen to you? Well, an easy way to do it is sort of just take God outside of time. So he's kind of looking across the whole of history, so he can see what's happening today and then what you're going to do in the future. And then that makes God timeless. So look, I can certainly follow the logic. It makes sense, and I've thought about that myself as well. The question, though, is this, is that we don't just want to follow the logic where it goes. We want to know what God is really like. So, for Einstein, he needed to know, is God personal or not? He reasoned that God was not personal, whereas the God of the Bible reveals himself to be personal. And so the question we need to ask ourselves is, when God reveals himself to us, is he eternal or is he timeless? And that is the really important question. And I've got a book as well. I could wave it to you. You could have a look at where there's a whole chapter that looks at these idea whether God is timeless or whether he's eternal and temporal.
What's that book?
And that is the book on cosmology, exploring our universe. And one of the key things is that it was the Greeks who thought that God was timeless. If you go into the Hebrew thinking, God is eternal and temporal, which is very important. And there's two reasons that we could think about that. And first of all is this: the incarnation of Jesus is actually a powerful demonstration that God is in time itself. So because there was a time before Jesus was incarnate and there was a time after he was incarnate, which means that there was a temporal transition in God's experience or not nature, but his journey through. The other thing is this, and this is very important. If God is timeless, he doesn't actually know what time it is now. He can look over the whole thing, but he doesn't know where we are at. So he never really enters into our time. Whereas the Bible indicates that God is from eternity through to eternity. Now, coming back to this idea of, didn't God create time? And so that means that he is outside time. We could use an analogy, and that is this. Did God create morality, or is morality part of himself? And the Christian thinkers and philosophers have actually said, no, it's not that morality is outside God. He didn't actually create it. He is actually he defines morality himself. And in the same way, God's time is metaphysical. There's metaphysical time, and God's time actually defines our time. So, and there's another reason we could look at it as well. So I get lots of ideas on this topic, is that God is Trinity. And for Trinity, there needs to be a relationship and dynamics. And that points towards God being temporal, being actually that God is there's a time aspect to God. There's a temporal dimension to God. So look, I can certainly understand what people would sort of go like, I figured it all out. God views the whole thing of time. He created time. Therefore, God is timeless. But I want to really challenge each and every one of us and to say to you, let's think about this carefully. And are we following Greek philosophy and the Greek philosophy of time? Or are we actually following what the Bible teaches and the Hebrew understanding of God and recognizing that God is from eternity to eternity, but God journeys with us in time as well?
Wow. That was pretty impressive, wasn't it? Yeah. Do either of you want to comment further on that or have a different
Time's
view?
difficult to scientists to define. From memory, the best definition I've seen is time as a one-dimensional, unidirectional, one-value continuum. So, yeah.
Simple.
So, yeah, it's interesting. A lot of things we really don't understand. Yeah.
What I would say is this, is that I think in the modern era, we have bought into Einstein's and Minkowski's understanding of the block universe of space-time. And we believe that time is intrinsically connected with matter and space. Whereas I would say that time is not just connected with space and matter. There's something much deeper with time. But it's a very deep subject. You really have to think about it a lot. I recognise that. But the book is a really powerful argument, and also this idea that even in our Adventist church, we have this idea that God enters into our time every Sabbath, and that's more direct personal evidence that God is part of time, or God is part of time is part of God's experience.
Well, speaking of bending time, you're bending my thinking on this topic, so I appreciate it. I'm thinking about it, and over time, my opinion is forming. Yeah. That's very interesting. All right, thank you, Sven, for elaborating more on that, because we've talked about that before, and you go very deep on that topic. John, another question relating to your talk earlier, your sermon. Are the Armenians the same as the Ashkenazi Jews? Because I think you mentioned the Armenians were descended from. It's not the same.
All I know is from my reading of the literature, what I put on my notes up there, that's the connection. So I haven't spent a lot of time, digging deeper than that, rather than looking at the historical origin of some of these cultures. But the histories branch out very quickly, so I can't answer that. Something somebody would have to research. Yeah.
Okay. Yeah, we could probably do more research on the Table of Nations and all that kind of thing sometime. I'm interested in that topic. Sven, a question for you, I think. Is there a purpose to the rotation of the moon on its axis that matches, we're talking about tidal locking, matches its orbit to show the same rate, the same face always to us? It even matches the change in speed of the Earth.
Yeah,
Why?
That's a good question. What is more significant, I would say, is that the size of the moon at its distance from us is the same size that the sun is from our distance to the sun, which means that when they are aligned, we have a total solar eclipse. And that is very amazing to experience. But it also does demonstrate, or you can have measurements in terms of the bending of light around objects which have gravity, which demonstrates Einsteinian theories of relativity as well. But you really have to stop and ask yourself, with Saturn, with its 274 moons, and with the other planets out in space where there's lots of moons, why is our moon the right size, the right distance? Why do we have our tidal system? All of those kind of things. It really points towards the fact that God actually designed and created our solar system so that we could explore and understand the universe. I'd also add, just quickly on that, is that the moon is gradually retreating away from the Earth as well, which actually points towards the Earth itself, the planet being young. So I would say there's lots of aspects of the moon which is really, really powerful and supports creation. In terms of it always having the face towards us, personally, I haven't come across any specific things which demonstrate why that is the case. Maybe John and Neville do, but those other aspects are very, very powerful.
Thank you, Sven. Now, the next question, I think, Sven, you might have been the one to put in my pocket, or maybe you paid someone else to do it for you. But maybe Neville could start off with his thoughts on this, because you spoke about it in the children's story. What is your evidence that there were dinosaurs on the ark?
That there were
Dinosaurs on the ark, yeah.
Okay. Can I make just...
Don't forget,
sorry,
Mike.
can I make just another comment before I do that?
Go for it.
I meant to say this morning that because the ark was double the width, double the height, and 6 times the length, that would mean that its capacity was 2 by 2 by 6 times this church. And so therefore its capacity was 24 times this church. But that's not taking into the account either of that going in. So I would suspect that the ark would have about 30 times the capacity of this church. And remember, there were 3 levels. And remember that Noah and his family and all the others that God made provision for, but who turned it down, could have been on a level. The animals on another level, maybe the birds up with the people. And the 3rd level could be for,
Dinosaurs.
Yeah. Now, having said all of that, what was your question?
So the question was, do we have any good reason to think there were dinosaurs on the ark?
Oh, yes. Okay. Well, there's clearly some evidence that there was some creature that may have been a dinosaur with all the dragon stories. They can't be just fiction. They come up time and time again. There are certainly records in the fossil record of dinosaur prints. And I know this one's a bit debated, whether there are human footprints with them. But there seemed to be some evidence around. I don't know if there's a mystical creature that could have been a kind of a dinosaur still in the middle of Africa somewhere, but you do hear of these reports. So I guess what I should say is they probably were on the ark. And anyway, the scripture does say, and you know, I know some say they might be augmented species and so on, but I think I choose to believe that God created them, created big animals, and the Bible says that all of the animals went onto the ark.
Yeah, thanks, Neville. Now, we are running out of time, but Sven and John can probably comment on this tomorrow. So if you haven't already registered for tomorrow, make sure you register. You can just register before you get there tomorrow morning. There's a couple of similar questions to each other which also will be addressed tomorrow, but we might just quickly try to get a bit of an answer on strobolites are said to be living or organic. How come they're found in 1,000-year-old rocks in the Pilbara? Any comments? We're actually having two different talks, I think, on radiometric dating and trying to date rocks, trying to work out the ages of rocks tomorrow. But does anyone want to say something maybe before they give their talk? Give a little pep talk for it first.
Stromolites?
Yeah, strobolites.
Oh, yeah.
Yeah.
They're over in Western
related
Australia
question.
in Shark Bay and stuff, aren't they? Go past where they are.
Sorry?
Yeah, over in Shark Bay and this sort of thing. The significance is something to do with, because I think they photosynthesise, don't they, or something? And yeah, it's supposed to be some intermediate in the evolutionary processes. Yeah.
So
Sorry,
maybe
I can't remember that much about it.
we might look into them tomorrow a bit more, I think.
Do a bit of research.
Yeah, do a bit of
Or
research.
somebody else can.
Yeah.
Go to sleep.
So the plan for the program tomorrow, these three will all be speaking tomorrow as well. We also have some other speakers as well. Instead of having a longer form presentation, there'll be short presentations, sort of like TED Talk length, and then there'll be an opportunity to have a little discussion among the group in a table, and then to share a question to be discussed with the whole group. So more interactive, more direct interaction tomorrow. So please register if you haven't already, and if you want to come. And there's a fee which will cover the program and also the lunch as well. So thank you all very much for attending. May God bless you, and may He go with us from this place. Shall we pray? Our Father in heaven, I thank you so much for the great wisdom and insight and experience that has been shared by these three men in particular today. And Lord, I pray that you would continue to guide us and teach us. I pray that you would take us safely home and bring those who are coming tomorrow safely back here. And Lord, I pray that you would bless each one here, that we would be able to be witnesses of your beauty, of your grandeur, of your creativity, and of your willingness to reason together with us. I pray that we would find Jesus, that we would find salvation in him as we reason, as we get to know you in a personal relationship with Jesus. I pray this in Jesus' name. Amen.
Amen.